In this video, we're going to take a look at eye shaders in Unreal and Unity. Let's go! There are two interesting things about eye shaders that I want to point out right at the start. First, eyes are considered the window to the soul, so when you look at someone, chances are you're looking right at their eyes. This means that people will spend a much larger percentage of time looking at the eyes of a character than anything else. And so you should spend time making sure that the eye shader looks really good. And second, eyes are relatively small, which means they don't take up a lot of pixels on the screen. And because they're not using a high percentage of the screen, they're cheaper to render. Both of these concepts together mean that it's okay to make the eye shader a bit more expensive to calculate than some of the other shaders. Before we jump into the game engines, let's take a look at the anatomy of an eye to determine what features we want to create in an eye shader. First, the eye is roughly round in shape with this bulge in the front called the cornea. The cornea is completely transparent, and we look through it to see the colored part of the eye, the iris. Because the cornea is round and transparent, the iris behind it is refracted. So as our point of view changes, the shape of the iris changes because of that refraction. And the refraction will be a key element of our shader. The hole here in the middle of the eye is called the pupil. The pupil changes size as the iris expands and contracts to control the amount of light that enters. In a dark environment, the pupil will be large, and in a bright environment, it will be small. Changing a pupil's size isn't strictly required for the shader, as it's a subtle effect, but it does add some nice realism. This outside white part of the eye is called the sclera. It usually has some nice red veins running through it, like you can see here. So we'll want to capture that in the texture that we use. And the sclera and cornea are kept wet. So we'll want to give the shader a high smoothness value or a low roughness value in Unreal. Now, one thing you may be thinking is, this is really complex. How am I going to make a shader that does all of this? And the answer is, you don't have to, because both Unity and Unreal come with really nice eye shaders already, including really nice textures. And you can just use them just as they are. And that's my recommendation. Both companies have worked really hard to make their eye shaders as realistic as possible, so let's just use the shaders they provide. So first let's take a look at the eye shader in Unity, and then we'll switch over and take a look at Unreal's eye shader. To grab the eye shader in Unity, first open the Package Manager. So we'll go up to Windows and Package Manager. Next, select High Definition RP, and then pick Samples here. And the eye shader is in the Material Sample, so you want to make sure that the Material Samples here is imported. All right, next we're going to go up to File, Open Scene, and we're going to go to Samples, High Definition RP 15.0.1, Material Samples, and then we're going to open the Scene's Eye, and that will bring us to this file here. Now this sample file has a lot of different scales of eyeball, and what they want you to see is that the correct human scale of an eyeball is 25 meters. So we're going to select this one right here, and I'll hit F just to zoom in on it. So there is our correct human scale eyeball. Now, the eye shader in Unity is designed to work with this particular mesh. If I select the mesh here, what you can see is that the mesh is normally a meter in diameter, and it's been scaled down to 0.025 or 25 millimeters, which is the size of an average human eye. And the shader is designed to work with this particular mesh that's a meter and then scaled down to 25 millimeters. Before we take a look at the shader, let's look at the mesh and the way it's set up. So I have the mesh opened here. It's called humanEyeModel.fbx, and you can find it in the assets. Probably want to just go ahead and import this FBX file directly into Maya or whatever software you use for creating your characters, and use this particular mesh because the shader is designed to work with this mesh specifically. You can see that it's basically a round sphere, but there is this nice bulge in the front for the cornea. And also if we take a look at the UVs are unwrapped so that the textures can be projected basically from the front. If we switch back to Unity, you can see that there's this stretching on the side here because the textures are basically just projected from the front. And you don't normally see the back part of the eye, so this little amount of stretching is okay. You normally just see, this front part. All right, let's also take a look at the textures provided in the sample. So here are the textures for the eyeball itself. You see that the sclera has some nice red veins flowing through it. And then here for the sclera, we can see a normal map with some really nice bumps so that it's not just a perfectly smooth eyeball. Then for the iris, you can see that they provide several different colors of iris, including one that's basically a grayscale. And this one you can adapt, so you could colorize this to be whatever color you wanted, which is fairly nice. The one that's being used in the example we're looking at is here, this nice brown one. And my favorite texture is this normal map that's being used for the shape of the iris. Normally we think of the iris as a flat structure, but it's really not. Inside, behind the cornea, it has these really fancy looking filament structures. And this normal map just captures all of that, and I really love it. The iris is actually a muscle structure that's used to contract and change the size of the pupil here in the middle. And you can see that muscle structure here in the normal map for the iris. All right, well, let's switch over and take a look at the properties of the material. So this material is using a new feature in shader graph called material categories. And we have things grouped. So we have sclera properties, iris properties, pupil, limbal ring, cornea, and geometry. So the properties are really nicely grouped, and it makes it easy to know what's going on. So the first properties that we have are the sclera, and you can see that we have the two textures here for the sclera. And then we have this nice slider that allows us to control the smoothness of the sclera. So we want to keep it fairly nice and smooth, kind of like we talked about before. So there you can see the specular highlight on the sclera, and we can control the smoothness using this slider. We can also control the strength of the normal map. So if we want a bumpier one, we can do that if we want to, or a smoother one also if we want to. All right, the other thing that's important to get right is this sclera diffusion profile. So this is the little document that contains the information about the subsurface scattering of the sclera. And it's important to use this one. And it's also important to make sure that your project settings have this in the list. So let me show you how to do that really quick. If we go here to edit project settings, and then go to graphics, HDRP global settings, we scroll down and find this list of diffusion profiles. So here you can see I've added the iris diffusion profile 25 millimeter to my list of diffusion profiles. The subsurface scattering won't work correctly if this isn't in the list. So make sure that the sclera and iris diffusion profiles that you're using are added to this list. All right, let's switch back to our material again. So we talked about our sclera diffusion profile, and we also have an iris diffusion profile because there are different characteristics of subsurface scattering on the sclera and the iris. All right, so for the iris, you can see that we have our color map and our normal map. We have this slider which allows us to offset the iris to the left or to the right if we need to, center it a little bit better. And we also have this color here that allows us to clamp or control how bright that iris can get. And then this also controls the strength of that normal map that's inside the iris. So if we zoom in here, if I crank this up a little bit, you can see now the normal map is a little bit stronger. We get more influence from that normal map. All right, here we can control the pupil. And like I was talking about before, this iris is a muscle and expands and contracts. So if we grab this pupil aperture value here, we can make the pupil open up larger for if it's a darker scene and the eye needs to let in more light, or we can shrink this down and make it smaller if it's a really bright scene. We also have controls here for the minimum pupil aperture and the maximum pupil aperture, so this will allow it to get larger or smaller if needed. All right, the limbal ring is not something that we talked about when I showed the anatomy image, but the limbal ring is this black ring. It's the border in between the sclera and the iris. So if we open this up, you can see that there are controls here for fine-tuning the size and shape of that limbal ring. Then we also have one control for the cornea. This is for how smooth the cornea is, and we probably want to leave that at 1 because it's wet and nice and shiny. But maybe if it's an older eye, we might want to bring this smoothness down, or if it's a dry eye, we could reduce the smoothness value here, but I would say generally want to leave that at 1. And then we also have controls for the caustics. Now, because there's refraction happening on the cornea, it bends the light a little bit and makes a really interesting looking highlight separate from our specular highlight that we have here. So if we turn this up, you can see that the light is being bent and focused on this portion of the iris. So that's what the caustic pattern is doing, or the caustic is doing. We can increase that and we can change the amount that it's blending with the iris itself. So you can see that as we move around, the light is being focused differently, kind of being bent and creating an inner specular highlight. So we have a specular highlight on the cornea there, but we also have a larger specular highlight on the iris. So really nice. So that's how the eye shader works in Unity. If we want to take a look, here is the shader itself. You can zoom out and you can see that this file is fairly complex. Unity's HDRP has a bunch of nodes that are made custom for the eye shader. If we take a look at the nodes available here, if we go to Utilities, High Definition Render Pipeline, you can see that the eye shader has a bunch of nodes that are specifically made just for the eye. And that's because the eye shader is fairly important. We want to make sure that the eyes look as realistic or as nice as possible. So this portion of the shader up here controls the sclera, including the 2 sclera textures, the controls for the limbal ring here. And then this portion down here controls the iris. And especially important, we have the refraction node here that creates that refraction. So if we come back to here to the scene, we rotate around, you can see that as we get to this point of view, that iris is warped and bubbled by the refraction that's going on and kind of bent in the direction of the cornea. And then it kind of flattens itself out as we look at it more from the front. So you can see that refraction happening there. All right, cool. So that's how the eye shader works in Unity. Like I said, my recommendation is to just use this shader as it is and apply it to this mesh, and then apply that mesh to your models. It'll be really nice to have all of these controls. If you need to do some other things, like maybe add a control for the color of the iris, you can definitely do that. You just need to come into this shader file and this shader file rather, and maybe make a copy of it, and then make whatever changes you need. All right, let's switch over to Unreal and take a look at the eye shader there. All right, here we are in Unreal, and I have the MetaHuman sample project loaded. So we're looking at the eye shader created for the MetaHumans. Here is the material instance, so we can take a look at all the properties that are exposed for this particular eye shader. The first thing that I want to take a look at is these textures. So here's a texture that's created for the sclera, that is the veins. And you can see that there's a separate texture that's just the sclera itself. So by separating out these 2 textures, they're able to create a control that controls how much of these veins show. So eyes that are bloodshot might have more veins visible, and eyes that are just normal and healthy might look more like this. So they can fade between these two textures to control how much these veins actually show. Then we have this texture that's a height map that's similar to that normal map that we looked at in Unity. This defines the shape of the iris and allows us to have some interesting shapes in the iris itself. So if we zoom in here, we can take a look, and if we move around, it looks like the iris is not exactly flat, but it has some really nice shapes, and that's based on this iris height map. Then we also have this iris mask map that has various characteristics of the iris stored in the different channels. So this channel stores these fibrous threads in the iris. This channel controls or contains the map for kind of like these muscular structures. Here's a nice fade between the outer part of the iris and the inner part of the iris, which could be used for a color blend between an inner and an outer iris color. And then here's just a mask for the pupil in the middle. So we have this texture that has 4 masks for the iris. And then just like we have 2 different textures for the color of the sclera, we also have a normal map for the regular part of the sclera and a part for the veins, so that we can blend between the smooth sclera and the vein sclera. All right, my favorite part of this shader is the way that they've used parallax occlusion mapping. So let's switch over to the shader really quickly. It's a fairly complicated shader, but here in the middle you can see that they have the MF parallax occlusion mapping I node applied. And if we take a look at the material again, so here I've got the shader applied to a box because I think it's the best way to illustrate this parallax occlusion mapping. Obviously this box is just flat faces, but as we rotate around, you can see there's some really nice refraction happening here in the iris. It really feels like there's some depth in there, and that this iris is being refracted by the cornea because they're using that parallax occlusion mapping. If we come down here to the refraction portion of the settings, you see I can grab this and change the index of refraction here to control how much of that refraction is actually happening. So that's a really nice effect, and you can actually see it here in the scene on the real eye. This inner part of the iris feels like it's recessed in when it's actually just, a smooth piece of geometry with no interior. But because they're using that parallax occlusion mapping effect, it makes it feel like that portion of the eye is actually recessed in, and it's a really, really nice effect that they're achieving there. Okay, so here at the top we have controls over the iris, and we have controls over the iris generator. Here we can control the different colors, we can control the refraction, and we can control the sclera. So as I said before, they have this control here for how much of the veins we want to show. So we can do fall off, we can make really bloodshot eyes like this, or we can tone out the veins and just make them appear, right around the edges. And we can even do rotation on the veins to give some variety. If every character is using the same eye shader and they have the same veins pattern, you can use this rotation value here to break that up so that characters' eyes are a little bit more unique one from another. All right, so you can see that there are tons of controls here, and you can play around with these obviously to discover what more of them do. But it's good to understand that we have iris controls that are controlling what's happening here. We have the iris generator controls that are controlling like the pattern that's happening here inside the iris. And we have the refraction controls, like I said, that are controlling how this intersection of the iris is refracted by the cornea. And then we have the sclera controls, which are controlling like these items on the outer edge. If we switch over to the sphere, you can see that the eye doesn't look right, and that's because the actual eye geometry is different that's intended for this shader is different from this this default sphere that's used in the previewer. That's why you get this stretching here and why the iris shape is not correct, and that's because this default sphere has different UVs than the actual mesh that's intended for this shader. All right, if we take a look at the shader itself, there's a couple of things that I wanted to point out here. Over here, you can see that we have this feature level switch. And what this is doing is it's switching back and forth between two versions of the shader depending on the feature set that's available on the machine that it's running on. So this is the best version of the shader, and this is kind of a fallback version that's happening here if the hardware isn't capable of doing the nicest version. So we have the default version and we have the ES3-1 version. You can see that the nice version is using the eye shading model, but the fallback version is just using the default lit shading model. So if the hardware that we're running on isn't capable of doing the fancy stuff, we can fall back to this version. So that's pretty much all that's doing there. Now we can see that we're generating our base color up here. We're combining the sclera color and the iris color. And over here, we're creating the specular. Here, we're creating the iris color using this MF iris generator. If you want to have some fun, take a look at this material function. They're doing some really interesting things to generate the iris pattern there using the iris mask that I showed you a minute ago. Here, obviously, we're doing that parallax occlusion mapping for the refraction in the iris. And then here we have the controls for creating the scale of the pupil so that we can animate that pupil size. I guess I forgot to show you that, but we can use this pupil scale here to open and close the iris to change the size of the pupil, just like we did in Unity. All right, so that is the Unreal Eye Shader. And again, there's a lot of complexity here, but you don't really need to worry about all of the complexity. You can just use this as it is and use their controls. Obviously, if you want to go in and simplify things a bit, you're absolutely welcome to do that. If you want to make the shader just a little bit cheaper, maybe you don't need all of these exposed controls and you can just use hard-coded values instead. You could go through and kind of clean this up and just expose the controls that you wanted to make the shader cheaper. You can absolutely do that. But anyway, that is the eye shader in Unreal. So I hope you've enjoyed today's video. We took a look at eye shaders in Unity and Unreal, and we kind of established that both companies have done a fantastic job of creating these tools that are available to use for users right out of the box. So in next week's video, I think we're going to take a look at hair shaders. So that one should be interesting. Make sure to come back for that. And in the meantime, have a great week, everybody.